Hello and good morning everyone. Today we'll be starting our Arduino tutorial series. So to start with, let's log into this website called tinkercad.com. This will give us virtual access to Arduino. Press sign in and sign in with Google. As you can see, I've logged into my account. My account has led me here. Now go to the circuits tab. And as you can see, I already have two circuits for today's video. For you won't have any circuit, so press create new circuit. Let me open up our first circuit. In this circuit, we'll be trying to make an LED turn on and off at specific intervals. As you can see, I have opened up my circuit. So now we'll add all these things required. Let me just search for an Arduino Uno. And I need a breadboard. I need an LED. I need a 220 ohm resistor. And that's about it. Of course I need wires, but in this the good thing is you can just click two pins and it will create a wire for you. So you can replicate this process in real life as well, but I'm doing it on a virtual website because that's safer. Let me just remove that. So now every LED has two pins, cathode and anode. Anode is positive and it's longer. With the resistor, let me just make sure it's a 220 ohm resistor. So now that I know it's a 220 ohm resistor, let's just wire this LED up. So I'll connect the positive pin of this LED to pin number D13, which means digital 13 on the Arduino board. I'll change the color to red because red generally signifies positive. And with cathode or the negative pin, I'll connect it to ground. Now as you can see, this breadboard's pins are aligned. You can see this breadboard's pins are aligned horizontally while these pins are aligned vertically. So basically what the breadboard is doing is it's connecting this terminal to this end of the wire. So let's get into the code bit of this project. As you can see, we already have some code. I'll just remove all that. Now every Arduino code must have two blocks, the setup block and the loop block. Without these, if I run the code without these two blocks, I'll get an error. So if I don't have the void loop, I'll get an error. Or if I don't have a void setup, I'll get a similar error. See? So let me add the void setup back. So to make the LED blink, I'll create one variable. You can think of a variable like a bucket. It holds values, and the variable of type int holds an integer. So I'll name this variable LED pin, and you can equal that to D13, or simply you can write 13. Now you must add this semicolon after every single line of code because this is like a full stop to the program. So if I don't add that, it's going to give me an error saying comma or semicolon expected before void. Let me add that back. So in here in the void setup, I'll add pin mode. what pin mode does is it tells Arduino which pin we will be using. So the first value we give is the pin we are using, in this case LED pin, and next we write what we'll be using the pin for. In this case we'll be using the pin for output, so write output. You could also write input in it if you're using the pin to input stuff. We use input for buttons. Now what I'll do is I'll head on to void loop, which runs as long as your Arduino has power, and I'll say digital write, which writes out a digital value to the pin, and I'll write the pin number LED pin, and I'll write the value I want going through that pin, which is high. So if we run the code right now, it will just turn on, which is well half of what we want it to do. We also want it to turn off. I'll add a delay block, which what it does is it pauses the program for a specific value of time, 1000 milliseconds, because it accepts values in milliseconds, is 1 second. Then I'll write digital write again, and I'll say LED pin low, because we want it to turn off. For low and high you could also use 0 and 1 if that will be clearer for you to read through, but I'll just use low and high. Again, I want it to wait for a second before turning back on. So what is happening here? Is Arduino is reading this and saying, well, I'll remember LED pin is 13. Then when the Arduino goes to pin mode in void setup, and it sees LED pin and is like, oh yeah, that's 13, and it sees that we'll be using it as an output pin. So let's save this code and head over to the next block of code. As you can see, it says all changes are saved, so I'll close this and head over to potentiometer analog write. So to start with here, what I'll do first is I'll quickly add all those components required. Now that I have all the components, I'll wire the LED as I did before. So now with the potentiometer, the center pin, also known as the wiper, will go to pin A1. You could send it to any analog pin really. The terminal 1 will go to ground, and the terminal 2 will go to 5 volts, which is positioned right here. This part of the tutorial is to teach you another method like digital write named analog write. So I'll start by making the same code as I did last time, void setup and void loop, and this time we'll be adding 3 variables, all of them ints. The first one will be LED pin, which is pin 13. The second one is the pot pin A1. The third one will be pot val. For this one I'll not specify any value yet. In the void setup I'll add 2 pin modes, one for the LED and the other for the potentiometer. And here in void loop I'll specify the value of pot val to be equal to analog read. What this function does is like digital read, it reads a value from an analog pins, which is how A1 gets its A, analog, and D13 gets its D, digital. So in here I'll specify pot pin, and to control the LED brightness I'll do analog write, which is like the digital write we used, takes 2 values. One is the pin number of the LED pin, and the second is the value we need to output through the LED. So now the code should work. Let it load. Now that it has loaded, as you can see, when I turn the potentiometer, the brightness of the LED changes. And you might have noticed after a particular point, the LED doesn't brightens or dims any further. Like you can see, after this position, it won't gain any brightness. That's because the LED has reached its max brightness and it cannot get any more light out of it. So that's it for this video. We'll soon be back with another good episode. See ya soon. Bye.